Hi, I'm Yves Rosto from Jean Blou Agrobiotech, and I'm here to give you some information about repeatability and reproducibility estimations. What is repeatability? Well, IPPO standard define it as the level of agreement between replicates of a sample tested under the same conditions. Replicates should be complete independent samples, not just repeated measure on the same aliquot. An agreement is met having the same result, whether those results are correct or not. EPPO standard define the reproducibility as the ability of a test to provide consistent results when applied to aliquots of the same sample tested under different conditions, for example, time, person, equipment, location. In the context of a ring test, it's often defined as the agreement between laboratories, which combine different time, person, equipment, and location. We choose to measure repeatability through accordance, defined by Langton in 2002, as the number of pairs of test results on replicates with concordant values divided by the total number of pairs of results on replicates. So it needs true replicates to be estimated. It can be evaluated at the sample level, at the laboratory level, or globally for a method. Sample and laboratory level are useful to track outliers, such as problematic samples or underperforming laboratories. Method level is used to compare repeatability between methods. To calculate it for a given sample, if a laboratory has n results and k of them are positive, then the accordance for that sample is calculated as k multiplied by k minus 1 plus n minus k minus 1 divided by n multiplied by n minus 1. Numerator is proportional to the number of pairs with the same value, and the denominator is proportional to the total number of pairs of results. Based on this equation, laboratory and method levels can be calculated by summing numerators and denominators and calculating the ratio between those sums. Here we have an example of repeatability accordance calculated for different laboratories and methods. And we see that one laboratory has a repeatability which is lower than all the others, which perform very well with a 100% accordance. So we can go back to that laboratory to see what went wrong with some of their results. Along with accordance, we chose to measure reproducibility through concordance, also defined by Langton in 2002, as the number of pairs of test results on sample replicates with concordant values, but between all laboratories, divided by the total number of pairs of test results on sample replicates, but also between all laboratories. It can be evaluated at the sample level or globally for methods, but no more at the laboratory level because it needs the results of all laboratories to be evaluated. Sample level is useful to track outliers, and again, method level is used to compare reproducibility between methods. To calculate concordance, let capital N and capital K respectively be the total number and the number of positive results for a sample across all laboratories, and Ni and Ki the total number and the number of positive results in the highest laboratory. Concordance for this sample can be estimated by the formula on screen. Again, the method level of the concordance estimation can be calculated by summing numerator and denominator across samples and dividing the results to get the new concordance for all samples. Method with unstable results will lead to weak accordance and weak concordance. So, to interpret concordance, we have to compare it with accordance. This comparison is eased by the calculation of what we call the concordance odds ratio. Concordance odds ratio is equal to accordance multiplied by 1 minus concordance divided by concordance multiplied by 1 minus accordance. If the concordance odds ratio is about equal to 1, the variability of the result between laboratory is negligible. If the concordance odds ratio increases, the variability of the results between laboratories increase also. How do we define a limit? What is a low COR or a high COR? Where is the limit? Well, this limit can be statistically tested through a Fisher exact test based on laboratory's results for a given sample. If the p-value of the test is higher than 0.05, so we can accept that the concordance odds ratio is about 1 and that the variability between laboratories is not significant. If the p-value is lower than 5%, then we have to reject this hypothesis and then accept that the concordance odds ratio is significantly higher than 1 and that the variability between laboratories is significant. Thank you for your attention. If you have any question about this topic, my email is here on the screen.